Hello everyone. So previously we had successfully designed a job queue processor, right? So today we are asked to design a code compiler service. Let's see what the question states here. Design a simple in-memory Python code compiler service that allows users to submit Python code. So this is one of the important things. Users to submit Python code, safely execute it inside a restricted sandbox. So this is one of the thing with the timeout protection and return either the program output or the error message. Yeah, the system should store all the submitted snippets and allow fetching execution history fully. Yeah, runnable in a single Python file without any external dependencies. Yeah, so this is the question actually. Yep, let me read it again. Just listen to this carefully. We have to design a simple in-memory Python code. We don't have to worry about the any external database, right? In-memory Python code compiler service that allows users to submit Python code. Users should be able to submit the Python code, safely execute it inside a restricted sandbox. Yeah, safely execute it inside a restricted sandbox with timeout protection. So we have to go with the timeout protection. We have to provide timeout protection and return either the program output or error messages. Program output, we should be able to return either the program output or the error messages. Yep. The system should store all the submitted snippets. Yeah, this is fine. And allow fetching execution history, right? Fully runnable in a single Python file without any external dependencies. The simple one. Yep. So let's do one thing. Let's collect this one, the functional requirements as well as the non-functional requirements in detail accordingly with the question so that we can move on with the solution part, right? So first, as usual, let's collect the functional as well as the non-functional requirements. So the first one, user submit code, the first requirement. The second requirement, system stores code and compiles or executes it in the sandbox style actually. Yep. System stores code and compiles or executes it in the sandbox style. Third one, system returns output or error messages. So this one is very important. System should return the output or error message. That we have to take care of. So this is one of the important requirements. Yep. Let's move on with the fourth one. System keeps history of the submitted programs in memory. Right. So they have asked us just to go with the in memory. System keeps history of the submitted programs in memory. Right. Also, system provides APIs. APIs for what? For submitting the code, nothing but submit of code. For running this one, running the code, run of ID and the history as well as they have asked in the requirements. Yeah, these are some of the functional requirements that we have to take care of, right? So non-functional requirements. So the code must be secure. So this is fine, I believe. Code must prevent infinite loops. Yep, nothing but the timeout. Yep. So this is one of the non-functional requirement as well. Must provide isolation for execution. Yeah, so this is one of the important requirement as well. The code must be fast, lightweight, and single file runnable. Yep, so this one also we have to take care of. Yep, the final one here would be code should not crash. This one crash entire service. Code should not scratch. Sorry, code should not crash entire service. Right. So this is one of the non-functional requirement as well. Yep. So next, let's move on with the algorithm choice and the design pattern choice. Yeah, let's move on with the algorithm choice as well as the design pattern choice. The first one here, so mainly based on the requirements that we have discussed, functional as well as the non-functional requirements, accordingly with the question, I found these algorithms that we can make use of, right? Algorithms rather than the algorithms, it's approach. Yep. So we can just go with the sandbox execution using Python's exec, right? Nothing but the Python's execution. This one, exec, right? So we will be going with the sandbox execution using Python's exec, right? Next, we will be going with the timeout protection using threading as well as the join of timeout. Yep. So this is also one of the thing. And in-memory repository using a simple list structure. We'll be going with the in-memory repository using a simple list structure. Uh, these three things will be making use of Python's exec, threading plus join of timeout, and a simple list structure. Python's exec for the sandbox execution, threading plus join of timeout for the timeout protection, and simple list structure for the in-memory repository actually. So this will be our algorithm choice. Yeah. So this is simple. Yep. I hope this part is completely clear. As we are done with the algorithm choice, let's do one thing. Let's move on with the design pattern choice. Yeah. Let's move on with the design pattern choice. For the design pattern choice, first thing we'll be going with a command pattern. Yeah, we will be going with a command pattern. So every code execution is treated as command. Yeah, every code execution is treated as command. So we'll be making use of the command pattern, repository pattern, as well as the facade pattern. Yep, command pattern. Yeah, every code execution is treated as command. If you know the command pattern, you'll be knowing what I'm speaking of. If you don't know the different design patterns, again I'm telling, we have discussed different design patterns, and the videos are present in the this one design patterns playlist. Actually, we have discussed using the Python programming language as well as the JavaScript. Yeah, whichever you are comfortable with or whichever you are preparing for. Now we are going with the Python. It's better if you follow the Python one. Yep. So yeah, we will be making use of the command pattern. Every code execution is treated as command. Yep. So we will be making use of the repository pattern as well. Um, so for the in-memory storage for code snippets. Yeah. So we will be making use of the, finally we'll be going with the facade pattern as well. So here compiler services or compiler service exposes simple API hiding the complexity. That is the reason we'll be going with the facade pattern. So we will be making use of the three patterns here. One is command pattern, the second one is repository pattern, and the third one is facade pattern. Yeah, these are some of the three patterns that we'll be making use of. Yep. So this is fine, I believe. Next, what we will do after the algorithm as well as the design pattern choice, we will be moving on with concurrency and the data model part. Yep, concurrency and the data model. First, let's discuss about the concurrency. When it comes to the concurrency part, each code execution runs inside a thread, right? Each code execution runs inside a thread. Yep, to enforce the timeout. Each code execution runs inside a thread to enforce the timeout. Yep, so this is fine, I believe. And shared resources, nothing but history of list, protect using Python's thread safe operations. Yeah, shared resources, nothing but the history of list. They have asked in the requirement this one. Yep, protect using Python's thread safe operations. So this is about the concurrency part. Next, let's move on with the data model. For the data model part, just pause the video and have a look into it. We'll be going with code snippet of, we'll be considering ID as well as the code string for the code snippet. For the execution result, we'll be going with the success output as well as the error as per the requirement. Yep. So this is about the data model part, and this is stored in the simple Python list acting as a in-memory repository. They have not asked us to go with the external database, so we don't have to worry about the this one much about the data modeling part, because designing in memory this one designing in memory is easier compared to the real this one databases actually. Yep. So we have to consider so many things when it comes to the database. Yep. Not entirely different, not entirely difficult, sorry. You have to have the knowledge on the databases. Yeah. So that's what. So in memory is somewhat easier, right? As we are just solving the problem, we'll be considering in memory itself. Yep. So we'll be going with the code snippet and the execution result. Code snippet of ID, code string, execution result of success as well as the output and error. Yep. This we have to take care of. Next, let's do one thing. This one we have went with you. Yeah. We have discussed algorithm choice and design pattern choice. And previously we had discussed the concurrency as well as the data model part. So based on this, whatever we had discussed earlier, so I have designed an UML diagram, right? So let's discuss the UML diagram now. So first thing here would be this class actually, compiler service class. Yeah, compiler service class is the base class actually. So this is the base class. Yeah, compiler service is the base class which consists of one parameter. Yeah, which consists of one parameter named repository, and it consists of three methods as well, right? So it consists of compiler service class consists of three methods as well, namely submit of code, run of ID, and the history, as we had discussed earlier. This one. Yep. So it is completely this completely uses the repository class as well. A compiler service class completely uses the repository classes, where the repository class consists of the one parameter named snippets actually. Yeah, one parameter named snippets, and it also consists of the two methods actually. Yep, it also consists of two methods, namely add of code and get of ID. It consists of add of code and get of ID. So these are the two methods the repository class consists of, right? So this is fine, I believe. Next, finally, we will be going with the execution engine class as well, which consists of only one method, actually nothing but execute of code. Yep, execute of code. Yep, so these are some of the three classes that we'll be making use of. First class is compiler service, which consists of only one parameter named repository, and it consists of the three methods as well: submit of code, run ID, and history. And this is going to be the base class or the main class. And compiler service classes completely uses the repository class actually. Yeah, repository class, which consists of one parameter named snippets and two methods, namely add of code and get ID. And we'll go with the third class named execution engine as well, right? We should be able to execute the code. For that, we'll be making use of the execution engine class, which consists of only one method, nothing but execute of code, the parameter code. Yep. So yeah, the same exact thing will be we should be able to articulate in the form of code. Yep. The same this one, what do we call, uh, classes will be making use of the same this one parameters and same methods that we'll be making use of within our code, within the code that we'll be writing in the future, right? The same exact same classes, exact same methods, as well as exact same parameters that we'll be making use of within the code. Yep. uh, Within the code that we'll be writing in the future, right? The only thing is we will be writing the code structurally, and also we will be adding the logic to the methods that we have considered. That's the only thing that we have to take care of. Yep. So now we have discussed the algo and design pattern. Yeah, design different design patterns that we'll be using. Based on that, we discussed the concurrency and the data model part as well. Based on what we had discussed earlier, so we have successfully designed the UML diagram part. We completely know how to write the code now. Yeah, what are the things that we have to include in code? Everything we have discussed. It's very good time to write the code. Let's start writing the code. So let's start writing the code. So first thing here, let's import the threading module. So basically threading module is used for running the user code with a timeout thread. Yep. So I'll just go with import here. I'll just go with threading actually. So this is fine. The next one is we have to import the input output as well, IO. The third one is import system actually. Let me go with this. So this is fine. And to redirect this one std out, right? Standard output actually. We'll be making use of sys module and IO module just for capturing the printed output. Yep. So finally, we will be importing the traceback as well. So let me go with traceback, this module, just to capture the error stack traces. Yep. So now, accordingly with the UML diagram that we have discussed, first let's go with the code snippet class. Yeah. I'll just go with this one, code snippet. Yeah, code snippet. This is the class, right? So within the code snippet class, let's go with the initialization part. I'll just go with init. So yeah, along with the self, I need certain parameters actually. Let me go with SID, nothing but the snippet ID, and let me go with the code as parameter, right? So I'll just need to this one. What do we call? Initialize certain things actually. SID, nothing but the snippet ID, and the final one is this one. What do we call? Code. Let me initialize this one with the code actually. This is fine. Next, let's do one thing. Let's go with the execution result class actually. I'll just go with class. Let me go with execution result. Yeah. Let me go with the execution result. This is fine. I'll just go with init in it. So along with the self, let me do one thing. Let's go with certain parameters here. I'll just go with the success. Let me go with output. For the output, let me assign this one to empty string initially, right? So let me do the same thing for the error as well. Let me assign this one to empty string, or let me initialize this one with the empty string. Yeah, within the initialization part, first I'll just go with a success here. So let me copy this one and let me paste it over here, right? So I'll just initialize this one with a success. Yep. What we are doing here, so we are checking whether execution was successful or not. For that, we will be making use of this. Yep. So next, let me initialize output actually. This part, let me copy this one and paste it over here. Let me initialize this one with the output. Yeah. So this is the captured standard output for the code. And also we will be going with the error as well. Yeah. So let me copy this part. Let me paste it over here and let me initialize this one with a error as well. This part. Yeah. So this is the captured error text, nothing but compile or runtime. Yep. So next, let's do one thing. Let's move on with a repository class. Yeah. So I'll just go with class repository. Yeah, class repository. So within the repository class, the first thing, let's go with the initialization part. I'll just go with init. So this is fine. Along with the self, let's do one thing. I'll just go with here this one. I don't need anything as parameter. I think we just have to initialize the snippets to the empty list, right? So we are just going with the in-memory list, storing all the snippets. Yeah. So next, what shall we do? I'll just go with the method add actually. Yeah. So I'll just go with the only one parameter as discussed in the UML, nothing but this one code. Yeah. So within the add method, first we have to go with each new snippet. This one, each new snippet gets the sequential ID, right? So we have to go with the sequential ID at any cost. So snippet ID, let me assign this one to the this one snippets dot length or length of snippets actually. Yep. I'll just give snippets here. Yeah. This is fine. Next, let me consider the variable snippet and let me assign this one to the, let me call code snippet class here and let me pass snippet ID along with the snippet ID. We need code as well. We have considered this one within the parameter, right? So I'll just go with uh, this one. We have to append the snippet to the snippets, individual snippet to the snippets. Actually, I'll just go with snippets dot append. What we have to pass snippet, right? So this is fine. The final one is we have to return snippet ID. We have to return the snippet ID. Next, what we will be doing, uh, so we will be going with a get method actually. Yeah, def get. Along with the self, I need only one parameter, nothing but SID, nothing but the snippet ID. So we have to return the snippet if valid ID. Else we have to this one none. Else we have to display none, right? If zero lesser than or equal to snippet ID SID, less than actually length of this one. What do we call snippets? Let me go with the snippets here. This is fine. Then let me return certain thing here. A return. I'll just go with the snippets actually. Let me go with the snippets of SID. So this is fine as well. Next, all we have to do is we have to return none, right? So we have to return none. Yep. So this is fine. Yeah. Next, let's move on with the main thing. Nothing but the execution engine. Yeah. Just give me a second here. Yeah. Let's go with the execution engine class actually. Let me go with execution engine. So within the execution engine class, first let's go with the execute method. Let's go with the execute method. So within the execute method, let me go with the code actually. Yeah, code as parameter. Right. So the first one, let's go with hmm, output capture here. So let me go with the output capture. So let me assign this one to the input output module. We have already this one imported the input output module. Let's make use of input output dot to string. Actually this has to show, not showing. Let me type this one anyways. String input output. Yep. So this is fine. Let me pass the parenthesis as well, and let me go with the error capture as well. I'll just go with error capture. So let me go with the empty string. Yep. So this is fine. Next, after the execute method, let's go with the target method here. So we need the target method. So within the target, what shall we do? The first thing, I'll just go with no local. Yep, no local. Let me pass the error capture. Right. So I'll just go with the error capture. Right. So let me go with the error capture. So this is fine, I believe. Next, let's do one thing. So why this is no binding for the non-local error capture? One second. Yeah, what mistake I have done here is basically we have to move this one inside the execute method actually. Yeah, so I'll just come here. Yeah, I have to write it over here actually. This one still showing there. Expected intended. We are going with the intended this one itself, right? Just give me a second here. If target. So is fine. And let me go with non-local. Now this is not showing error. Anyways, I'll just go with error capture. Yep, so this is fine. Next, what we will do, let's go with a try and accept method. First, within the try method, we have to restrict the built-ins for the safety, and also we have to only allow print, right? So we have to block all others. So I'll just go with a restricted globals. Let me go with the restricted this one globals. So within the flower bracket, so let me do one thing. I'll just go with built-ins. Yeah, let me go with the built-ins. So this is fine. Yep. So I'll just go with here. Mm, print as parameter, and let me go with the print actually. Yep. So this is fine. Next, what shall we do? Why we are getting error here? Right. But at least have one expect. Yeah, we still haven't written the accept, right? So we'll be writing that one later. Next, first, let's finish off with a try actually. We have to redirect the standard output to our string input output buffer. So I'll just go with SYS. We have imported the SYS module already. I'll just go with a standard output std out. So let me assign this one to the output capture. Let me this one with the output capture. The final one is we have to execute user code inside a restricted sandbox, right? So I'll just go with exec. So I'll just go with a code along with it. Let me call the restricted globals, this one. Yep. So this is fine, I believe. Next, what we'll be doing, let me go with except this one, except, yeah. So let me go with the exception. So this is fine as well. So within the exception, first in case of runtime error, we have to capture the stack trace, right? So I'll just go with error, this one error capture. So let me assign this one to the trace back. So this is fine. Dot format. What we need to format here? Format exec. So this one itself. Yep. So the next one would be we'll be making use of the finally keyword here, right? So we'll be making use of the finally keyword here. So within the finally keyword, so we have to restore the standard out back to the original. I'll just go with sys dot standard output. This one, yeah, std out. So let me assign this one to sys dot. So let me go with the standard output. So this one, yep. So this is fine, I believe. Next, what we will be doing, if I'm correct, so let me go with this one. We have to run the code inside a thread to prevent the infinite loops, right? So I'll just consider thread variable here. I'll just go with threading dot thread here. Not this thread, yeah, this thread itself. So let me assign the target to target. Yep, this one. Yep, so this is fine. And let's start the thread actually. I'll just go with thread dot start. So this is fine. Yep. Next, let's do one thing. We have to wait at most 2 seconds before killing the runaway code, right? So I'll just go with thread dot join. Yeah, thread dot join of 2. So this is fine as well. Yep. If thread is still alive, then we have then it means that code took too long, right? So see, let me write the simple if condition here. If thread dot is alive actually, let me go with is alive. Then what shall I do here? Within this, let me return something. So I'll just go with return execution result. So this one, yeah, this one execution result. So let me pass false here. So this is fine. Also, let me assign the error to, I'll just go with timeout. So this is fine, but infinite loop detected, right? I'll just give this one for the interactiveness, right? So within the string, just we are passing we are passing the message. Yep. So I'll just go with infinite loop detected. Yep. So this is fine, I believe. Next, let me do one thing. Let's go with a simple if condition again. This time, see, previously, if the thread was still alive, then code took, that means the code took too long. Now, if the Python error occurred, then we have to return it. Then we have to return the error, right? So for that, let's write the simple if condition. If error capture, then within the if condition, let me return what we have to return. Execution result actually. let me go with the execution result, this one. So within this, let me pass boolean value false initially, and let me set the error. I'll set the error to error capture, right? So this one has to show this one. Yep, so this is fine. We are done with the uh, condition as well. If the Python error occurred, we have to return it. Otherwise, what we have to do? Otherwise, we have the successful execution. Then we have to return the captured output, right? So in our case, let's do one thing. I'll return so successful execution, right? So I'll just go with execution result again. So within this, instead of false, let me pass the true here. Along with it, let me go with output capture. This part, actually, I'll just go with a get value, right? So let me go with a get value. So this is fine, I believe. Yep. So after this, what we are going to do? So we are done with this particular class. Yeah, we are done with the class execution engine. Now, accordingly with the UML diagram, we are left with the base class or the main class. We are left with only one class, nothing but the base class or the main class, nothing but compiler service, right? So I'll just go with, sorry, class. Let me go with the compiler service, right? Compiler service, right? So within the compiler service class, first let's go with the initialization part. Let me go with init. So this is fine. Yeah, within the initialization part, we have to store the snippets and we have to run the snippets, right? So I'll just go with a repo. So this is fine. Let me call the repository here. Yeah, let me call the repository here. So this is fine. And let me go with engine here. This one, self-prot engine equals, let me call the execution engine. So this one, execution engine. Yep, so this is fine. Next, what we're gonna do? So we will be going with a certain methods, three methods as per the this one UML diagram, right? Submit, run, as well as the history. First, let's go with the submit method. I'll just go with submit. Yeah, so this is fine. Along with the self, actually, let me do one thing. The first parameter that I'll be making use of here will be code, right? So within the submit method, we have to add the code and we have to return the ID. So I'll just return here, repo dot add. We need to add the code, right? So let me pass the code here. This is fine. Next, let's move on with the next method, nothing but run. Yep. So we have to retrieve the snippet by ID within the run method. That's what we have to do. And we have to execute the snippet code at the end, right? So if the snippet is not found, we have to return false, Boolean value false, and we can give some message as well within the string. And finally, we should be able to execute the snippet code if everything goes right. That's what we have to do, right? I'll just go with here, def the method run. So within the run, let me go with the snippet ID, nothing but SID, right? So this is fine. Let's retrieve the snippet by ID. So I'll just go with snippet. Let me assign this one to the repo. Yep, repo dot get of, let me pass snippet ID. Yep, let me pass the snippet ID. Yep, so let's do one thing. Next, let's go with a simple if condition. If not snippet, this part, then what I'll do, I'll just return, what should I return here in this case? Let me go with the execution result. Sorry, not the execution engine. We have to go with the execution the result actually. Yep. So here, if the snippet is not found, or snippet was not found or is found, we have to return the this one. What do we call? False, Boolean value false, and set some message within the string. Error equals snippet not found. So this will be relevant here, right? So I'll just give snippet not found. Yep. So this is fine, I believe. Next, let's do one thing. We have to execute the snippet code. For that, I'll just return. So what should I return? I'll just go with self dot engine. This has to show. Yep. So I'll just go with execute. This has to show as well. Yep. And let me pass the snippet dot code. Code has to show. Yeah. No, it's not showing. Let me copy this one. Type this one entirely. So this is fine. Now we are done with two methods. We are left with only one method, nothing but the history. Accordingly, with the criteria of the question, we have to return the list of ID or code base, nothing but we have to save the history, right? So in that case, we have to save the history, and if asked, we should be able to return it. Yep. So within the history method, we should be able to return the list of ID comma code base. Yeah, this one we know. I'll just go with history here. Yep. So within the history, Yeah, I'll just return the list of ID comma code paste, right? So I'll just go with return here. So in this case, let me give snippet.id. So this is fine. I'll just go with snip.code. This is fine as well. So why this is showing error here? 1 second. Let me write this one for entirely. Then the error will be gone. For snip actually, for snip in dot this one repo dot snippets actually. Yep. So now the error is gone. Yeah. So let me close this one actually. What happened? So let me remove this one. Now the error will be gone. Yeah. Now the error is gone. So we are making use of the snip here, right? So that we can make use of snip.id here and snip.code. Yep. So we are done with the coding part. So this is it. Accordingly with the UML diagram, we have written the code. We have added the logics to the different methods, and we have made use of the same classes parameters as well along with the methods. And we have written the code structurally along with adding the this one logic to the methods. Actually, we are done with this part actually. So we are done with this part. Now let's do one thing. So let's add or let's do one thing. Yeah, let's go with the demo execution of the this one example usage, demo usage of the example usage. Right. I think I don't have to explain the code again, whatever the code that we have written. So this one we have discussed the UML diagram and other stuff earlier as well. So based on that we have written and we have discussed the same thing while writing the code as well. Every single step we went step by step, right? So I think we don't have to discuss this one again. So let's move on with the further part. So I'll just let me go with the demo usage or the example usage. Usually I get the demo usage or the example usage from the Google. Let me do that. Just give me a second here. So let me copy paste this one. So first I'll run the code and let's discuss the output part. Yeah, if everything goes well. So the code has to run successfully. Let's check the same actually. Just give me a second here. Yep. I'll just come here, give Control J. This is fine. Python followed by the file name dot py. So we are getting error. Execute input output at string IO. What happened here? Module IO has no attribute to string IO. Did you mean string IO? Yeah. What's the wrong here? Oh, S has to be capital S here. I have given capital S. Right? So where line number 44. So let me check this one once. What's the wrong thing? Where is it? Yeah. Within the execution engine, right? So 1 second. We are going with the string IO itself, input output. So here, let me do one thing. I'll just go with yeah, this one is showing now. What's wrong here? So let me go with clear screen. Cannot join thread before it is started. Yeah, thread dot join of two, line number 66, where it is 66. This is within try in the execution engine. What's wrong? Actually, we are going with 1 second. So what we are doing here? Def target thread dot join. 1 second. So yeah, what mistake I have done here is see, this is simple mistake actually. I have this one. What do we call? Have not given parenthesis here. If I don't give the parenthesis here, the code will break actually. Yep. So let me add parenthesis over here. Start. It is showing in the line number 66 itself. 66 in the sense thread dot join actually. This one will not work as well. Thread dot join of two, right? If I don't give parenthesis here, the code will break actually. So let me give clear screen here and let me run this one again. Yeah, now see, we are getting the correct output. Yep. So what is the output that we need to get? Let's discuss this one. First, what we are doing accordingly with the example usage that we have considered. See, First, we are calling the compiler service. We are creating the compiler service instance. Next, we are just printing submitting code. Yeah, see here, submitting code is fine. Next, we are going with a snippet ID that we have assigned to service.submit print of hello compiler. User submits the code. So this is also fine. Snippet, this fine. This is fine, right? Next, what we are doing, running code. Running code in the sense, we are just printing the running code. So this is also fine. Yeah, result equals. We are going with a run method actually based on the snippet ID. First, what we are going with, we have to show the results back to the user, right? For that one, if the success, we are going with result.success. If we have to display the output, if it is success, we have to display the output. Out for the output, we are calling result.output here, right? So what is the output that we need to get? So we are we have submitted hello compiler, right? Hello compiler itself. Yep. Success, we are checking the success whether it is successful or not, right? So this should return the boolean value accordingly with the uh, accordingly with the code that we have written. If it is not successful, then we have to get the boolean value false. If it is successful, then we have to get the boolean value true actually. Yep. If it is successful, then we have to get the boolean value true. So in our case, it is successful. We are getting the boolean value true here. Next, what is the code that user has submitted here? In this case, we have submitted, or I am the user, right? So I have submitted hello compiler within the strings. So we are getting the output hello compiler, right? Hello compiler, which is absolutely correct. In the case of error, we are just going with the result dot error. In our case, everything went well, so we are getting the success message, nothing but the boolean value true and the output hello compiler, right? So there is no error, so within the error we are not getting anything. Yep, so we are getting the desired output accordingly with the example usage that we went with actually, or that we are considering currently. Yep, so this is fine. Now we have got the desired output, right? So we have discussed the code step by step. We have discussed the output part as well. So we have got the desired output as well. Next, we are good to go with the this one, limitations of the code, limitations for the code that we have written. Yep. So the first limitation would be no true OS level sandboxing. We are not going with any this one OS level sandboxing. Exec is restricted but not perfect, right? So this is one of the limitations as well. We are not going with any true OS level sandboxing. Yeah. So we are just going with a very simple code. Yeah, just a single file CLI demo, right? So the second one is only Python code is supported. Here in this case, only Python code is supported. No multi-language. This one support. Yeah, no multi-language support. We are not supporting any other programming languages other than the Python. Only Python code is supported. So this is one of the limitations as well. The third one is timeout is completely thread based. Yeah, timeout is completely thread based. Yeah, this is one of the limitations as well. The fourth one is no persistent storage. No persistent storage in the sense, yeah, no persistent storage. Yep, we are not making use of any external database. So this is one of the thing. The final one is no load balancing of real container isolation. No load balancing of real container isolation. Yep. So this is one of the this one limitations of the code. Limitations for the code that we have written. Yep. These are some of the limitations. Yeah. Next, let's do one thing. Let's move on with the final one or the last thing. Alternative algorithms and the trade-offs. So here, let's move on with the alternative algorithms and the trade-off topic, right? So first thing, first alternative algorithm is, or the approach would be, so we can just go with a Docker-based isolation. Yeah, we can just go with a Docker-based isolation. So this is one of the alternative things that we can make use of. So what does the Docker-based isolation do actually? If you have any idea. So what it will do here, just 1 second, man. Did I miss anything? No, right? Anyways, Docker based isolation in the sense, so the main advantage of making use of the Docker based isolation is strong sandboxing and the multi language support. Yep. So we can just go with a strong sandboxing and multi language support. So this is one of the advantage, and the main con or the disadvantage is heavy. It's completely heavy and it requires external runtime. So yeah, it's not completely VS Code friendly as well. Yep. So this is fine. This we have to keep in mind. And the second one is AST based execution validation. The main advantage is it is safer. and it also blocks the harmful nodes. Yep. So this is one of the advantages, and this is one of the advantage. Sorry. And the main con or the disadvantages, it is complex to implement. It is complex to implement. Let's move on with the third one here. Dedicated worker processes. Dedicated worker processes in the sense, the main advantage of using it is killable processes through isolation. But the main con here would be requires IPC and more overhead. Yep, more overhead. So this is one of the cons actually. The final one is microservices architecture. We can just go with a or yeah, we can just implement the microservices architecture. So this obviously helps in the deployment, but the main pro is it's completely scalable and distributed. Quite obviously, helps in the deployment. And the main con would be this one. It overkills for the single file demo, right? So we're just asked to solve the problem. We're just going with a simple this one. What do we call? Single file, simple single file CLI demo, right? If you want to extend this one, we can just think of the microservices architecture as well. Always while writing the code, we have to keep in mind one thing, nothing but the extensibility. Extensibility is the pro factor that we have to keep in mind. We have to think of extensibility at any cost, and then only we should design the code and then we write the code. So we cannot this one deny or ignore the extensibility part at any cost, right? So yeah, these are some of the alternative algorithms and the trade-offs that we have discussed accordingly. Yep. So now we have successfully designed this one, code compiler service, right? So now we have successfully designed code compiler service. Next, we will be designing dynamic feature flag manager, right? So dynamic feature flag manager, right? So I hope whatever we have discussed is completely clear along with the approach, along with the coding part, sorry, along with the coding part and the UML diagram part, right? So for now, this is it. Thanks for watching, guys.